So, hello everybody, and welcome to this webinar, Passive Ventilation Units. We welcome you from Zehnder Group Sales International, and thank you for joining us today. We must say we have today an amazing amount of guests and from a lot of countries all over the globe. And yeah, thank you for joining us today. And my name is Willy Konstantinov. I'm product management here with Zehnder Sales International. And my colleague today will himself.
Yeah, hello everybody, and also a warm welcome from my side. My name is Adrian Gut, and I am working as a technical project engineer at Zehnder Sales International. And I'm very happy about that huge amount of participants today. We have more than 100 attendees from all around the globe. So thank you for joining us today. And really, I think it's our turn now to deliver good content. So
let's do that.
Let's start.
Let's do that. Okay. Well, Adrian, he joined, visited the virtual Passive House conference this year that took place during the year September till October, and where a lot of experts from all over the globe were together and discussed the Passive House certification and all the topics about building efficiency. Adrian, so why are we talking about this topic, and why is it so important to talk about building efficiencies?
Yeah, this is quite simple. You know, we have climate change, 200 states assigned to the Paris Agreement. So everybody who is watching this webinar is affected by this agreement. And we need to think about how to reach our climate targets. And firstly, we can do that when we use our energy in an efficient way. And secondly, we need to make use out of renewable energies to get CO2 neutral by 2050. And at this point, we need to take a look where we actually spend our energy. And therefore, prepared the following chart. There you can see the fire consumption in Germany in 2018 by sector. And what you can see here, that we need almost a half of the energy that we spend for heating and cooling. Only 30% are used for mobility and another 20% for electricity. So here you can see we have a huge potential to save energy in the cooling sector. So this is actually why we are talking about energy efficient buildings and their importance.
Amazing. It's amazing. Almost 50%. That's a huge amount.
Yeah.
Well, just to give you a little orientation about the presentation targets today. So Passive House is a topic, and how does it affect the building technology? And then we will switch over from the building technology itself and Passive House to actually Passive House certified units. And we will also talk about which units can be used and, for example, how also to obtain the certification. So, Adrian, tell us a little bit more about the Passive House. What is a Passive House?
Yeah, basically the Passive House is a building standard that is energy efficient, comfortable, affordable, and ecological at the same time. A Passive House only needs a very small amount for heating and cooling. Compared to the building stock, we have energy savings about 90%, and compared to the today, which we also call low energy buildings, we have energy savings up to 75% or even more. And to reach this energy savings, a Passive House needs to fulfill 5 criteria. The first one is the heating demand. The heating demand of a passive house is limited to 10 watts per square meter. As a comparison to the building standard today, there they have values from 30 up to 40 watts per square meter. And also the same applies for the cooling demand. There we have the same value. So a passive house cooling demand must not exceed 10 watts per square meter. And what is also very important, the whole primary energy demand must not exceed 120 kilowatt hours per square meter and year. Just for your imagination, this amount of 120 watts per cubic meter and year is equal to 1.5 liters of oil to heat up 1 square meter in a whole year. So this is a very small amount. And what is also very important for a passive house is the air tightness. There we need to reach a value of 0.6 or even lower. And you can measure this by doing a blower door test. What you are simply doing is setting the whole house into an over or an under pressure of 50 pascals. And then you are measuring the air volume flow going through the envelope, or if you have a pressure, the air volume flow which is going into the house. And this value must not exceed 0.6 times the whole volume of the house. Yeah, and compared to the building standard today, there they have values from 2 up to 3 times this in 1 hour. And we also need to fulfill thermal comfort criteria. You know, we have the thermal comfort conditions regarding temperature and humidity. Temperature between 20 and 26 degrees and humidity between 30 and 60 or 70% of relative humidity. And we need to hit this comfort zone throughout the whole year. Yeah, the organization behind the Passive House approach is the Passive House Institute. This institute was founded in 1996 by Mr. Wolfgang Feist, and it's located in Darmstadt in Germany. And Mr. Feist already built the first passive house in 1991. And you can see this on the picture on the right-hand side. This is the first passive house, and this is actually the own house of Mr. Feist. And there he could prove that his concept is working. Today, the Passive House Institute has more than 4,600 members in more than 50 countries. So it's all around the globe. The Passive House Institute is a leading institution for research and development of construction concepts. They are certifying the building components like our ventilation units, which we will see later on. They also provide planning tools, and they provide training programs for everyone. So architects and engineers could do such a course, and then they can get the certification of a passive house planner or a passive house designer to build these passive houses. And therefore, the end customer, the owner, that's the quality assurance by the Passive House Institute. And during the whole project of a passive house, the Institute also gives you technical support and consultants. Yeah, so they have done a lot of projects all around the globe, mainly for the residential housing, but the passive house approach is also applicable for offices, factories, schools, and even high-rise buildings, as you can see in the picture below. This is a skyscraper in Vancouver, Canada, which is about 80 meters high. And this skyscraper also got Passive House certified.
Pretty amazing. That's pretty amazing. But what even is more interesting is that you mentioned that before already. You mentioned air tightness, and you mentioned the heating or cooling demand of only 10 watts per square meter. I mean, that's really high values and or high to achieve. To achieve, how do we reach that?
Yeah, the passive house concept is based on 5 principles. The first one is thermal insulation. The whole exterior envelope needs to be very well insulated to reduce transmission losses to a minimum. And this also applies for the windows. So there are passive house certified windows which need to be used when you build a passive house. And these windows have the characteristics that they have a very low U value to reduce transmission losses. And the windows are also insulated, and they have the characteristic that they let in the sunlight on a very high amount, so they have a good transmittance to solar power. Another principle is the air tightness, as I already mentioned, and this is due to reduce infiltration losses. And another point are thermal bridges. They need to be reduced. So yeah, every corner, every edge, every connection of a house needs to be very well planned and also implemented or built it with a lot of care. Avoid thermal bridges in a passive house. And the main principle of the passive is even the system. If you imagine you take in the whole building envelope, in the air tightness and in the insulation, you have nearly no transmission losses, and you would just open the window in winter when it's cold outside, the concept would collapse. So you also need a ventilation system which has a heat recovery to also reduce ventilation losses. So at the end, you have nearly no energy losses in a passive house.
So to sum it up, it's the thermal insulation, the passive house windows, air tightness, the reduction of thermal bridges, and a good, comfortable indoor ventilation system with heat recovery.
Yeah, that's the point.
Well, so what does that mean for the building technology? I mean, if we assume a house with 150 square meter and multiply that by 10 watts per square meter, we get like 1.5 kilowatts. Do we actually need a central heating system?
Yeah, exactly. This is the point. We have such a low heating demand. Same applies for the cooling demand. For the single family house, for example, 1.5 kilowatt. And there is no need anymore for a central heating or cooling system, but there's amount which needs to be covered, and we can do that by internal gains. For example, you know, people are producing heat, they give off heat in an amount, an average of 100 watts per person. So for our single family house, we have 4 persons, 4 times 100 watts, we have 400 watts. And then we also have internal gains from our equipment. So for example, the fridge or the dishwasher or TV, they give off heat. But then we still not have enough heat for even the coldest days in winter. And then we can also make use of solar gains. You know, we have this passive house windows, and they have the characteristic that the sunlight can go through in a huge amount. So in winter, we want to have the sunlight entering our house to heat up our building. In summer, when it's hot outside, we do not want that solar gains inside our building. So what we are doing is a strategic shading concept. You can simply do this via blinds, or you can do it, as you can see on that picture, with an extended roof construction or with a balcony for the ground floor. Because, you know, in our regions, the sun in summer is standing at a very high level, whereas in winter, the sun is lower. So in summer, the sun is not able to enter our building. In winter, it is. So we can make use of the solar gains. And what we also do in our region, orientation of the house is towards south, so that we can make use out of the solar power. In other regions, for example, in hot climates, this is the other way around. So we have huge windows in the north direction, only small windows in the south. Yeah, and if this is still not enough, we are also allowed to use, for example, a post heater or even a cooling coil, or we can also make use of renewable energies like a brine earth heat exchanger to pre-temper the incoming air. For example, in summer, we can pre-cool the incoming air. In winter, we can pre-warm. Yeah, and for your for hot water, for your daily shower, this can be done by a solar panel on your roof, or you can also use electrical heater or a heat pump, but you still need to meet the criteria which I mentioned at the beginning related to the primary energy consumption. So you can see there are a lot of options, but the principle is clear. And so you can also see comes from. You do not need any active heating or cooling system anymore. You make use out of the passive energy which you have in your environment, from internal gains, from the sunlight, or in hot climates you can also make use out of ventilative cooling. For example, at night the temperature drops, and then you increase your volume going through the ventilation system to make use out of free cooling or passive cooling. We call it ventilative cooling. Yeah, so you see, the passive house is not just a low energy building standard, it's rather a whole concept which can be applied by anyone anywhere in the world. And this is what we can also see on the next slide.
Yes, so there are definitely some challenges. I mean, there are specific climate boundary conditions and also specific building traditions in every country or in every region. But the beauty of this principle is that actually the principle remains the same. The details, they have to be adapted. And as you can see in the lower section of the slide, Passive House divided our Earth, our globe, into 7 regions that starts from very cold and goes up to very hot climates. And also with the colored indication in the map, you can see the different regions that we have on our Earth.
Yeah, so do you have any references for these different climates as well?
Well, yes. So as we heard before from Adrian about the whole passive house concept, now we're making a little. We are switching to actually one of the principles, that is the comfortable indoor ventilation with heat recovery, and there are just some projects that we picked to show you today. There's, for example, a new build in Australia. There's a building or a house in construction in Argentina. And also, what's wonderful, Passive House isn't limited to builds and new buildings. It also goes very well with retrofits and renovation projects.
Yeah, so Willy, you know, there are many certificates available on the market. Can you tell us what is so special about that passive house certificate?
Of course. So now we are going into the section where we talk about the ventilation unit itself, right? And what is very important to know is also Passive House states that a highly efficient heat recovery unit is an essential component of the comfort ventilation in a passive house. And as this slide, if you look at that slide, this is not a comparison between the standards, but it's just an indication that we have actually very high standards according to the European laws and regulation. And on the other hand, this is an extra. This is the passive house certificate is something voluntary that is actually corresponding to the one of the highest independent energy standards worldwide. And as we can see on the left-hand side, we have European standards for performance testing of components and products, and performance testings of mechanical supply and exhaust ventilation units, including heat recovery. And also we have the Declaration of Performance, the DOP, where it's actually publicly accessible to see what a unit of any manufacturer is actually capable, how it's capable to perform, and you can see the values. So that's one thing, it's mandatory. So on the other side, we have these passive house standards that are actually equally valid worldwide. So they're not limited to local standards or to local organizations. And well, that's the beauty of that passive house certification. And it gives you a peace of mind if you want to realize some passive house projects in your country, in your region, or you just can be sure it's just a component, let me say in this case, a unit that is actually that achieves very high standards and gives you a unit where you can be sure that it will perform very well with your passive house project.
Yeah, okay. So now we know what is the certificate, but how can we obtain the certificate and what is the procedure behind it?
Yes. So actually, when we're thinking about certified passive house component, the development or the thoughts actually have to start already during the development of a component of the unit. The passive house criteria must be taken into account. And there's, for example, a strict criteria regarding, for example, air tightness and frost protection, which have a huge impact on the design and functioning of the unit. I mean, you need to imagine, I mean, you have to think about the components inside the unit, what quality the components must have, and how you put them actually together to achieve very high values of air tightness. And well, just again to compare a few values for the same unit, for example, thermal efficiency and specific electric power consumptions. So if we apply testings according to the European standards, a unit will receive 94% of thermal efficiency. Well, testing the same unit according to passive house standards will achieve 86% of thermal efficiency, and so on. And it doesn't say that actually, from a passive house perspective, this unit is not good. It just demonstrates that there are different criteria, and passive house requires a much stricter test procedure. Just for comparison, also you can see in the table that even with passive house standards, unit achieves 86%. the minimum requirement is still 75. So how to get the certificate is actually that you have to send in as a manufacturer a serial unit from your production. So you can't prepare this unit in a special way and put better components inside or something like that. It actually has to come from your production line, and you have to send it into an acknowledged notified body. This notified body is acknowledged by Passive House. Well, and with this test report, you can apply at Passive House for a certification. And just to show you how it looks like or where you can find it, just please, let's go very quick on the database of Passive House, where Passive House actually publishes publicly accessible the different certificates. So for example, yes, if you can type in the search section Zehnder, and then you have the whole list of Zehnder units with certifications. Yes, and just to keep on talking about the ComfoAir Q350 unit, there's some general information, and then if you click on the certificate that is always also available in English, you can look into the certificate and also can download it for your own purposes. So all data is actually publicly accessible. So, and just in the data bank, we saw the certificate for cool climates, but just very important info. So at this point, that the Zehnder ComfoAir Q350 ventilation unit is at the moment the only unit on the market that also carries a PHI certificate for very hot climates. So what are some of the criteria? Well, I mentioned before already the efficiency. So the effective heat recovery efficiency must be higher than 75%. Air tightness, leakage should not be greater than 3%. The unit must be balanceable. Sound absorption is also a topic. Room hygiene. So for example, an outdoor air filter has to be at least an ISO EPM 150%. That is better known as the F7 filter. As frost protection is a criteria. The comfort, that means that at the minimum supply, that is minimum supply air temperature of 16.5 degrees Celsius has to be provided at a -10 degrees Celsius temperature outside. And also the electrical efficiency, that the total power consumption of the unit may not exceed 0.45 watts per cubic meter and hour.
Yeah, so now it's also interesting to know which units from Zehnder can be used to build a passive house and to get a certification. Can you tell this, really?
Yes, of course, and with much pleasure. You actually have your peace of mind. This is a view into the overview of units in our current price list, and centralized units as well as the decentralized solution by Zehnder. Every unit carries the Passive House certificate. So you have your peace of mind going on with your project, and with Zehnder, you have definitely one of the principles with the ventilation unit as a certified component. You definitely have this covered. So at the end, Adrian, costs play always an important role of a project. Maybe you can tell us a little bit about that. Are the costs much higher realizing projects following Passive House standards compared to a standard building?
Yeah, sure. This is always a big question, the costs. So what we have heard from different building professionals from different regions where they have different climates and where they have different building traditions is that they all say, yes, it is possible to build a passive house with their existing knowledge, with their existing experience, without any further huge investments. For sure, you have a higher investment for the better windows, the thermal insulation, and the ventilation system. And it also takes more effort to plan this and to do the construction of a passive house. But on the other hand, you do not have the costs for a central heating or cooling system. And what is also seen in a lot of countries, that the government supports such projects. So they give financial support by building a passive house. And what is also visible, the long-term effects by the energy savings. So you are saving energy costs. So for our region, that would mean you do not have a heating bill anymore. And also you are not linked to rising energy prices, which is also important. And at the end, you also have other benefits, like you are doing something for your environment. You make use out of renewable energies. You do not have a CO2 footprint. And also you have thermal comfort in your passive house, and you have a very good indoor air quality provided by the ventilation system. So to summarize, to build a passive house is quite affordable compared to low energy buildings. And you also get this additional benefit with the return of investment. Yeah.
That's great. That's great. So as now the costs are covered, let's give to our guest the chance to ask us some questions.
Yeah, you can use the chat session to ask any questions, and we will answer to that.
Are there any questions?
No, not so far.
Not so far. Okay. Well, if you will think of any question or any feedback after that webinar, here in this slide you can see our email addresses, and you also, if you don't remember it, you can just send an email to Zehnder Group Sales International, and we will then come back to that later and answer your questions. Well, at this point, we would like to say thank you for joining us today. It's the last webinar for the year 2020, and again, we are very amazed and yeah, love it that we received so many registrations and so many positive feedback. After this webinar, you will receive a quick follow-up email. Please give us your feedback there about the webinar, and you will also get the chance to register already for the next webinar in January 2021. And yes, write us an email if you have topics that you would like to discuss further. And be aware of that we will upload this webinar on YouTube. Please leave us a thumbs up if you like this webinar. Use the comment section and ask us your questions, or let us know what topics you would like to see in our next webinar. Then also we want to prepare content that you would like to know or to see. Yes, so from my side, thank you very much. Bye-bye.
Yeah, thank you. Goodbye.